All right, so after you've reviewed those topics on evaluating logs and rewriting them in log or exponential form, you can move on to these three properties of logarithms. So there are three main properties, and later on we're going to be able to mix and match them together. But right now we're going to just look at them separately as three separate properties. So we have product property, quotient property, and power property of logs. Okay. And with this, we can simplify logs. We can expand logs to make them more doable with our, with our algebra skills. So we just need to know how to manipulate the problem so that we can condense or expand them. So it's so we need to know how to condense and expand using each of these three properties. Okay, so this first property for logs, well, actually for all three of these properties, you want to make sure that if you're condensing or expanding, the base of the log stays the same. So if you started off with a log of base 7 or something like that, when you expand it, each of the logs that you'll produce will also have a base of 7. Okay, so we'll do for this first example here. If I'm doing product property, and let's say I have a multiplication of a couple things. So let's say of x and y. I can expand this into two separate logs that are added together. So a multiplication of inside one log will get expanded into into an addition of two of those terms. So like we'll have log base 7 of x plus log base 7 of y. So if you notice, the x and the y's, the things that we're multiplying together, gets split up and they're now adding together. Okay, and my bases stay the same. So if I go backwards, I might be given something like this. I can now condense that down into a single log, but again, the bases for each of the logs must be the same in order for you to condense it down using this product property. So for this first example, log base 5 of 3 plus log base 5 of 7, both of these have the same base of 5 and they're getting added together. So what I can do to condense, okay, I'm going to condense this is I'm going to condense it down to a single log base 5, and each of those values now inside each of the logs are going to get multiplied together. So 3 times 7. Okay. So my final answer would be log 5 of 21. Log 5 of 21. And that's all I'm doing. I'm just condensing it down so that it's one single log. I can do the same thing for expanding now, right? I have one log, and inside the log I have two things multiplying together. I have a 5 times an x, so two values multiplying together. I can expand that into log base 5 of 5 plus log base 5 of x. Okay. So again, when things are multiplying on the inside, they will expand, and now you'll have two logs adding together. It'll turn to an addition. Okay. Let's look at quotient. Quotient, as you know, is a division. So very similar to what I have in this product property, quotient property. If I have division happening inside of one log, so let's bring it back to this example, log of 7, x divided by y in that one log, I can break it up into two separate logs, but now instead of adding, I'm going to be subtracting. Okay, so I'm subtracting these two logs so that I have two separate logs, same base, but they're subtracting if they are dividing in one of the logs. So let's try to condense this down. Let's condense this one down because now I have two log base e's, or we call them ln's, same base of e, and now they are subtracting each other. So what I can do is I can condense it down into one ln, and now the two values on each of those natural logs are going to be in a division. So it's 7 divided by x. So that's how we condense that down. It'll be ln of 7 over x. Okay. An expanding example would look like this. I have log base 5 of 10 over 7. So if you notice, inside this one log, you have a fraction, you have a division, 10 divided by 7. So what I can do is I can expand this so that I can have a log base 5 of 10 minus log base 5 of 7. All right. Lastly, we have power property. So power property deals with the power. So if you have an exponent inside that log, what you can do is you can bring it down to the front. Okay, so I'll show you what that looks like. 7, let's just use 7 again, and then x to the power of y. Let's say that. So now it's x to the power of y, not x times y, not x divided by y, x to the power of y. That y value can get brought down to the front and be multiplied to the entire log. So I'm going to do y times log base 7 of x. Okay, so all I'm doing is I'm bringing down this y power, and I'm bringing it into the front of the log, and that's the power property for logs. Okay, so if I'm looking at this condensing version, I have one example here of condensing. I have a 13 times log, common log of 3. Right? There's no base here, so I know it's common log base 10. Excuse me. So what I can do to condense is I can bring that 13 in the front back up to its power. So I'm going to write this as log, common log of 3 to the power of 13. Okay. So that would be the condensed version. All I'm doing is bringing that 13 back up to the power. Okay. Example number, let's do this second one first. Okay, so I have this power of 3 within my log. So what I can do is I can bring that power of 3 to the front of the log. So now I have 3 times log base 5 of 7, and the power of 3 is gone. It's now in front of the log as a multiplication. Okay. And that is expanding. Okay. This middle problem is also an expanding problem. Right? You actually see 2 powers, so you could actually bring it down twice if you wanted to. Right? So I'm going to bring down the 7. So now it's 7 times log base 5, 8 to the power of 3. But I can do this once more, so now it's 7 times 3 times log base 5 of 8. And that 7 and the 3 in the front can get added up together, so now you have 21 log base 5 of 8. You could have done that a little bit differently. You could have multiplied the 3 times 5, 3 and the 7 powers together first to get 8 to the power of 21, and then you bring down the 21, but you get the same answer eventually. Okay, so I know that I showed an example of just 2 things multiplying or 2 things dividing, or I only showed 2 logs being expanded. You can sometimes have it as 3. So I'm just going to show one quick example because that might show up in your assignment. But let's say I had something like this: log base 3 of x, y, and z. Well, now this time you are still doing product property because I have multiplications, but you're not just going to split it into 2 logs, right? I have 3 things being multiplied inside. So I'm going to split it up into 3 separate logs with a log base 3. So log base 3 of x plus log base 3 of y plus log base 3 of z. Right? So you can have something like that, and that's totally fine. Okay, for quotient rule, a little bit different. But I'm going to show you a shortcut here. If I have multiple things in the bottom in my denominator, like this, right? X divided by y times 7. So the y and z. Y and z are both in the denominator of my fraction, so they're both dividing. So what I'm going to do is every time I have that denominator will be subtracted when I expand it. Okay, so just like here, when I have x divided by y, it was log base 7 of x minus log base 7 of y. So whatever is in the denominator will be subtracted when it's expanded. Okay, so the answer for this would be log base 4 of x minus log base 4 of y, and an additional minus log base 4 of z, since both the z and the y are in the denominator. They both are subtracting when I do my expansion. So those are your 3 properties of logs. Again, later on we're going to be mixing and matching. So sometimes in one problem, when you want to expand, you're going to have to do product and power, or like product and quotient. But these are the 3 basic properties of logs that you will need to know. Again, make sure you do the evaluating stuff first before you do this. This is just a little extra for those that want to move on to the future lessons.